started with this session. You're all very welcome to our fourth conference on Ireland's COVID-19 crisis response, perspectives from the social scientists. My name is Orla Doyle from the School of Economics and the Geary Institute, and I'm going to be chairing the session today. So the purpose of this conference is to consider the likely implications that COVID-19 will have on society. And as we move towards a lifting of restrictions over the coming weeks, the issue of testing and contact tracing is going to become even more important. So in today's session, I'm absolutely delighted to be joined by 4 experts in the field to speak to us about the issues and challenges involved in testing and tracing. Our first speaker this morning is Professor Alex Friedrich from the University Medical Center in Groningen in Netherlands. Next, we'll have Professor Cliona O'Farrelly, who holds a chair in comparative immunology in TCD. Cliona will be followed by Professor Tomás, who is an associate professor in biochemistry, also in Trinity. And then finally, we'll have Professor Patrick Wall, who's the Professor of Public Health in UCD. So you're all very welcome. Thank you for joining this session. Just some basic housekeeping to start with. Each speaker is going to have about 15 minutes to talk, and then we'll have a 20-minute Q&A session at the end. Everyone in the audience, you're more than welcome to post questions during the talks. In your question, please just say who your question is directed to, and then in the Q&A session at the end, I'll work through each of the questions. Note that all of these sessions this session is being recorded and will be available on publicpolicy.ie afterwards. So with that, I think we're ready to get started. Now our first speaker today is Professor Alex Friedrich. He's not actually here in person this morning, so instead we recorded his presentation on Wednesday. So what I'm going to do is play his presentation now, and then we'll move on to our live speakers afterwards. But please feel free to post any questions that you have to Alex. I'll forward your questions to him afterwards, and then we can send the responses by.
So, good morning, everyone. And that was a fascinating talk. I come at this, just previously, the public health one, I come at this from quite a different perspective. I'm Professor of Comparative Immunology at Trinity College, and so that's my, that's where I come from. What I'm going to talk about today in 15 minutes, it's a huge amount. If we could do a whole course on this, a whole module on it, several modules. I'm going to mention a little bit about the virus, about how it gets into cells, about viral detection, and then the actual test for viral detection, and then how the immune system has an amazing detection ability for the virus. A little bit about the immune response, and I particularly want to emphasize that we have 2 major systems in our body: an innate immune response, very capable of getting rid of viruses, and as well as the adaptive, which produces the antibodies, which is the one that everybody, the immunological test that everybody knows about. So the virus, people have seen dozens of images like this, is a really magically designed little package of biology with a nucleic acid, which has some proteins as well attached to it, surrounded by a membrane which has proteins studded into it, in particular an envelope protein and the spike protein. And it's this spike protein that attaches to the cell surface and unlocks the cell so that the virus can get in. And so all of these components can be used in a vaccine. So first of all, there's major complexity in terms of what can generate an immune response. A wonderful PhD student in Trinity in genetics, Laura Finnegan, has done this beautiful image summarizing briefly how the virus, how any virus needs to take over a cell in order to make itself. So we're not clear whether a virus is actually alive or not, because it cannot survive on its own. It cannot reproduce until it gets into another cell. So again, a thing that's difficult for non-scientists is just how tiny all of this is. So we have literally trillions of cells in our body, and billions and billions in our lungs of epithelial cells that can be targeted by viruses. And the coronavirus gets into pneumocytes in the lung and then reproduces there, making lots more viruses. Soap breaks the coat protein, and that's why soap, washing our hands, is so important for keeping it away. As I said, the size here is really, really important, and it's very difficult to communicate even to our students. This is something that's really difficult to really conceptualize. We already know that red blood cells are absolutely tiny. It cannot be seen by the naked eye, around about 7 micrometers. So the coronavirus is 100 times smaller than a red blood cell. And this is an electron micrograph of actual coronavirus particles. And here they are lining up along the membrane of a cell. So this whole surface is just the membrane of a single cell. So this will give you an idea that the coronavirus is probably thousands of times smaller than most of the cells that it infects. And so therefore, once you want to kind of appreciate that, then it's easy to realize that they're very difficult to detect. And so the test for detecting detecting the virus is actually a technique for amplifying the nucleic acid. And this is a fantastic technique that the person got the Nobel Prize for, polymerase chain reaction. And it requires that you get some nucleic acid from the nasal swab, illustrated up here at the top of the figure in figure 1, and then little very precise markers are used to identify the coronavirus nucleic acid, and then that is amplified millions of times so that it can finally be detected. So you can visualize easily how this is a problem, because it's technically difficult to get this nucleic acid, to prepare it, and then to carry out the technique to amplify it, and to get an accurate result. So inevitably there are times when an accurate result is not obtained. So that's the actual test that is used, and we talk about testing. In the meantime, inside in the body, we have inside in the body, we're equipped with multiple mechanisms for detecting viral particles. And really, it's molecules that can detect components of the viral particles. So the body can sense what is going on inside it. The viral nucleic acids themselves are detected as non-self and therefore danger. And that detection activates antiviral mechanisms. So the image over on the right kind of summarizes this machinery that's inside many, many cell types, with the TLRs as an example, TLR7 in the middle, TLR7 and 9 as examples of these molecules that can detect viral nucleic acid and that switch on a series of pathways that ultimately lead to the messages to get rid of this virus. And mechanisms are actually activated within the cells themselves and within neighboring cells by these messengers. And in particular, type 1 interferons induce antiviral mechanisms in neighboring cells. Also, you get production of these messenger molecules, called cytokines. So this innate, we talk about this being the innate immune response, and it can be quite effective for clearing the virus. So this is an image of a row of airway epithelial cells with the little green viruses attacking here, and the production of these molecules, interferons, which cause antiviral mechanisms to be activated in neighboring cells. If that doesn't clear the virus, then these cytokines that are produced activate neighboring immune cells and the whole immune system in the body. So these messenger molecules are cytokines, are actually what make us sick. Cytokines can be produced by many types of immune cells and also other cell types, and they activate other cells, amplify activity, and then are actually what cause the inflammation that is associated with the major symptoms of viral infection. So it's really kind of interesting to think about what actually makes us sick, and it's the complexity of this cytokine release that makes it so difficult to identify what's different about this virus in comparison to the inflammatory responses that are generated by other viruses. And it really reveals our lack of knowledge in this area. Even though we know so much, we still know so little in comparison to what's needed to know. So some of these cytokines are, you'll have heard of IL-6 because that's been used as a target for potential treatment, but there are many others: IL-1, IL-17, interferon gamma, TNF-alpha, interferon alpha, and they all contribute to the features of general inflammation, which is temperature, pain, swelling, and heat, but also in their various combinations to the symptoms of COVID-19, which are illustrated over here on the right: the fever, the cough, fatigue. Type 1 interferon is known to cause depression, problems with the gastrointestinal tract. TNF-alpha is very powerful in there. And so because different people produce different amounts of these cytokines, then you have different types of response from very asymptomatic, as Alex has described in the previous talk, to mild disease, to very severe disease, and ultimately possibly death. So while that innate immune system is part of is a key part of the response to viral infection in getting rid of a viral infection, and if there's too much of it, as I've tried to illustrate, then you get the symptoms and severe illness. The inflammatory response is critical for activating the adaptive immune response, which is highly specific. So we talk about macrophages being the primary mediators of the innate and the producers of the cytokines, and T and B lymphocytes are the primary mediators of the adaptive immune response. And we know that there are coronavirus specific, SARS-CoV-2, which is the name of the virus, specific T cells, which are capable of killing infected cells. But the part of the adaptive immune response that most people are familiar with are antibodies. And these are very specific molecules that are produced by B lymphocytes, here illustrated covering the surface of the B lymphocyte and one attached to a little coronavirus. Again, the scale is way, way off. But a B lymphocyte differentiates into a plasma cell, which produces masses of antibodies. And most, our understanding as immunologists is that humans are capable of making many different types of antibodies to any virus. Now, the papers are coming out fast and furious on the antibody response, and some are clear, but many of them have not been reviewed. And so a very clear picture is still lacking as to whether most people make antibodies, what antibodies they make, how specific they are, and whether they work. So in the top left-hand corner is a study on 260 patients showing the trajectory of an antibody response days after symptom. We have two types, we have 5 different types of antibodies, but here people have measured IgM and IgG, and showing that you can start detecting antibodies about 2 to 4 days after infection and reach a peak about 17 or 19. Trying to generate an antibody response is what we try to do with vaccines, but it's not just any type of antibody response. We need what is known as a neutralization antibody. And so that's illustrated in the bottom left-hand image, where the antibody, if you have an antibody specifically against the spike protein, then it can block the binding of the spike to the ACE receptor on the cell type. And on the right-hand side is a prototype of an antibody test that might be used across huge numbers of people. So antibodies, in contrast to T cells, which are very specific T cells, which are very difficult to measure, antibodies usually are easy to measure, relatively easy, because they're soluble proteins, they're present in the serum, and there is evidence, or we know that the nasal passages are really good at making a particular type of IgA antibody, which may turn out to be very important in this case. and antibodies are stimulated by vaccine. The other major contribution of antibodies to this whole scenario is the possibility that we might use antibodies generated by recovered individuals in order to treat patients and to prevent the disease. So this, you may have come across the term convalescent serum. And so before we can do this effectively, we really need to know which antibodies are the protective ones, which are the ones that can actually stop the virus from getting into a cell and reproducing. So all of that research has to be done. But when that has been discovered, we would then screen people who have had the virus for these protective antibodies, ask them to donate a sample, separate out the serum, and from that the virus neutralizing antibodies, and then you would use this purified serum as a treatment option. And this has been used over decades as a very successful form of treatment in other viral situations where we don't have an effective vaccine, for example, in rabies. However, I hope I've given you, however, the immune system is complex, and I hope I've given you just a brief insight into that. And because it is so complex, then that means that our tests are far from perfect and far from suitable. So being able to detect a specific antibody response, just even focusing on antibodies, is problematic. Antibody tests vary hugely in sensitivity. That means in their ability to be able to detect antibodies that have been made. Not everybody makes the same amount, not everybody makes the same type. Is the assay capable of dealing with that variability? The other major problem is false positives. If you make an antibody test that picks up lots of people who are infected, it may provide it may pick up the actual wrong ones. So the specificity is the ability to be able to avoid false negatives. The other issue is this one that is most important in this particular case, is the variability in every individual, in the human immune response. So you've got already a faint idea of this from the point of view of the type of disease that people get. It can be asymptomatic, mild, or severe, or so bad that people die. Why is that? That is because of the enormous genetic variation in the human population and the fact that so many genes are required to make an immune response. So not every infected person will have antibodies. This will be because some viruses are not good stimulators of antibodies in general, and we know that about coronaviruses. There's also the possibility that coronavirus-specific cytotoxic T cells are able to clear the virus without the person making antibodies. So a person may well be immune, may well have an adaptive immune response, but might not necessarily have antibodies. And that would be only a proportion of people. And then there's a third immunological reason why some people will not make antibodies. There may be some, it's like some who are really efficient at making so much virus that they're super spreaders. There may be some people who have a super innate immune system, which is enough to clear the virus without involving an adaptive immune response, and therefore without making antibodies. And it's this very last point which I'm particularly interested in trying to identify people who are innately resistant to viral infection, in particular the coronavirus. So thank you. I look forward to any other questions.
Thank you, Cliona. That was excellent. You really explained some complex scientific concepts in ways that even economists will understand. So thank you very much.
Good. I'd love to hear. I'd love to discuss immunology with some economists. Thank you, Orla. Okay.
Many of us on this call. Okay, thank you. So now let's move on to our next speaker, Tomás. Do you want to share your screen with us? Tomás, yes, coming on.
Can you hear me all right?
I can hear you, and yeah, we're just about to start seeing your screen. Yeah, we can see your screen now.
Wonderful. Okay, I'd like to start by thanking the organizers at the Geary Institute for arranging these online meetings. I think they're extremely valuable in the current situation. I'm a neuroscientist and molecular biologist, and what I'm going to talk about here is my view for how we can have a scientifically orientated exit strategy for Ireland as we come out of lockdown and as we come to live with this virus over the coming years. The problem, it seems to me, is that we don't currently have a clear exit strategy for how to manage this after we come out of lockdown. And this is a significant problem for a number of reasons. We don't know how long we're going to have to wait for a vaccine. It could be optimistically 12 to 18 months. It could be longer than that. It's possible that a vaccine will not come at all. I'm more optimistic than that, but we have to be prepared for that situation. Furthermore, it's quite possible that there will be seasonal differences as we go from year to year. Therefore, I don't think a herd immunity approach is viable. And I don't personally think a herd immunity approach is ever a civilized way to approach this. So it seems to me that we need to have a way of managing this virus in the population that allow us to live socially and economically without having to deal with further unpredictable surges and lockdowns, which will happen multiple times, affecting our way of life and our economy. Now, the best analogy that I think is out there for thinking about the transition that we're currently facing was developed by writer and entrepreneur Tomás, who distinguishes between the hammer and the dance. The hammer being the suppression phase, the early suppression phase, where we prevent unmitigated exponential growth, reproduction of the virus in the population. This is to avoid the kind of scenario that happened in Wuhan and in northern Italy. And the idea here is to have very significant measures, such as lockdown, in order to get the reproduction number of the virus below 1. But then we need to transition to the dance phase. The dance phase means we want to keep the reproduction number of the virus in the population below 1, so that we don't have further surges, so that we don't have exponential growth. Now, the crucial thing about the distinction between these two things is that the dance has to be livable. The dance has to be something that applies to how we want to economically live and socially live, how we want to educate our children, etc. But it also has to be a situation that prevents further surges. It has to be a situation that prevents us going back to the situation where we have to use the hammer again. Now, what can be considered to be in common between the hammer and the dance stage is the tool of isolation. I'm going to talk about that a little bit later, because isolation is the only method that we have of controlling the virus. Now, in Ireland, where we are currently, we're coming to the end of the hammer phase, and the hammer has been very, very successful. We've still had probably more deaths than we would like. We've had slightly more cases than we would like. We could have had our lockdown a bit sooner. We could have limited travel a bit more effectively. We could have managed the nursing home situation a little bit better. But besides those situations, we've had a relatively successful lockdown, and the hammer phase is coming to an end. And now we need to enter the dance phase. Now, the problem for us is that when we enter this phase, which starts really on Monday, as restrictions begin to be eased, there are going to be thousands of active cases of this virus in the Irish population. And if we don't have an active way of suppressing the transmission of those cases, of the virus from those cases to other people in the population, we stand a very high risk of having further surges and therefore further lockdowns, maybe in September, as some of the previous speakers mentioned, but possibly even sooner than that. Now, what are our options for what we do now? I really do think that in the current public conversation surrounding what we're doing, we're not really discussing the options for what we can do. There's a lot of discussion about economic measures versus medical measures, and economic consequences versus healthcare consequences, and how we're managing children at the moment. But I think it's very important that the public understand that there is only a limited set of things that we can do. The first thing we can do is, of course, do nothing. I don't think anyone really wants that, but I think some of the narratives that we're hearing seem to imply that this may be an option. If we do nothing, we will have exponential reproduction of the virus, in intensive care units being overwhelmed, and catastrophic loss of life, as was seen in northern Italy. In Ireland, that could be anywhere between 50 and 100,000 deaths, and possibly the same again in future years if the virus changes. Now, the second, and I think the sort of passive option that we're sort of moving into could be called continued mitigation, which means we want to maintain the reproduction number below zero for 18 months or however long it takes to get a vaccine. And that we're going to do this by some combination of social distancing, which on its own is surely going to fail at some point, and what I would call active isolation, which means test, trace, isolate, which we are not currently doing sufficiently, but there are optimistic targets of beginning to begin doing this sufficiently starting next Monday. Now, while a continued mitigation approach that actively maintains a reproduction number of below 1 is a possible way of doing things, it still is fraught with risk because we're going to be bringing new cases into the country. And depending on how efficacious the infrastructure is, there's still room obviously for things to get out of control in some regions of the country, which would lead to potentially more surges. The third option is suppression, which would mean not just suppression for the lockdown, but a dance phase where we completely suppress the transmission of the virus in the population, where we would have effectively no new cases or negligible new cases going forward from here on out. Now, other countries have achieved this and maintained it to a certain extent. I think New Zealand is looking like an ideal situation to me. I think New Zealand could have been Ireland's situation. For various reasons it wasn't. The advantage of geography and early lockdown and heavy testing allowed New Zealand to now have effective suppression of COVID-19 that it is in a position to maintain. And I think that we should consider, can we actually achieve that for the island of Ireland? But we can't do it the way New Zealand did it, because we've already passed that opportunity, and we're dealing with a situation where even coming out of lockdown, we have quite a lot of cases in the country. So how do we achieve suppression by other strategies? And there's two main options here as far as I can see, two main broad options. One has been proposed recently specifically for Ireland, which is a heavy and prolonged lockdown, going for at least another few months to really eliminate the virus from the population. The second is what I would call a seek and destroy strategy, which would be modeled on what is happening very effectively in South Korea and Taiwan. Now, this is an analysis that was produced by Geary. Geary is a very accomplished epidemiologist at University College Cork, spent much of his career working in Africa. And Geary is arguing strongly for a suppression strategy in Ireland. And his argument for doing this is for the reasons I've already stated, but also so that we can completely crush the curve instead of just flattening the curve, and essentially reducing the total death number that we will have in Ireland through this entire pandemic. And to do so, Cliona is suggesting that we should have a slightly more robust lockdown. We've had a significant lockdown in Ireland, but it hasn't been the hardest of lockdowns when you compare us to, say, Spain, etc. So Geary is suggesting that if we have a longer lockdown for another 2 to 3 months, or however long it takes, we could completely eliminate new cases from the island and then have a suppressed situation going forward. And when we have a suppressed situation where there are no new cases, or effectively no new cases, everything can go back to normal, and we don't need even heavy social distancing, and everything will seem economically very much as it was within the country. I don't think personally that this is the strategy I would use. For one thing, it requires a much longer lockdown. I think a more severe lockdown, which requires social cooperation, which will have economic consequences. But mostly the reason that I don't like this approach is that after we finish it, we're still vulnerable to new cases. We're still vulnerable to new cases coming into the country and the things spinning out of control. And just as now, if we don't manage our exit strategy, it makes the lockdown we just experienced meaningless because it only buys us time. If we take a very, very long, severe lockdown to suppress the virus, we're still vulnerable to new surges in the future, and therefore making that very long lockdown also meaningless. So it seems to me that we need a more persistent strategy, and I would say rather than crushing the curve with a hammer, we need to pull it down with a set of scalpels. And we need to have a way of actively isolating cases and keeping any new cases out of the population in a, as I said earlier, in a kind of a search and destroy method. Now, isolation is the only tool we have against COVID-19 right now because there's no vaccine and there's no effective antiviral drugs. Isolation works very well. We know this. It's what we've been doing in lockdown. It's what we've been doing in the hammer stage. What we've been doing has been a blunt form of universal isolation. Universal isolation is both general and protracted. We're all doing it all of the time. And that has heavy collateral costs, and we don't want to continue doing this. So we need to transition to a form of particular isolation. And particular isolation means only isolating the people who have it or who are very likely to have it. Universal isolation works on the premise that we don't know who has it, so we'll isolate everyone. Particular isolation means we only isolate the people who we know have it, and therefore particular isolation requires specific currency, and that's information. We need to know who has it and who they've been in contact with. Now, the crucial thing to understand, which I think people in Ireland are becoming much more aware of, is that we spread this virus when we're pre-symptomatic. So if we get infected with SARS-CoV-2, we get symptoms of COVID-19 around 5 days post-infection. But we are spreading the virus pre-symptomatically in the population 2 to 3 days post-infection. And that 2 to 3 days window is very much the danger zone that we need to worry about as we exit the lockdown and enter the dance phase of managing this epidemic. Now, the other thing is asymptomatic transmission. Asymptomatic means someone who never gets symptoms, but is still spreading the virus. And generally speaking, most studies find that about 40 to 50% of people who are infected with SARS-CoV-2 are truly asymptomatic. And it is known that these people do spread the virus, but it is debatable how much the asymptomatic people spread the virus in populations. It varies from study to study, but it's very clear that pre-symptomatic people seem to be accounting for about 50% of the overall transmission of symptomatic cases. So obviously this is a huge problem. It is a problem that has not been adequately recognized or discussed in Ireland. And it is absolutely crucial to engineering a suppression strategy or even an adequate mitigation strategy for the next year and a half that requires a test, trace, isolate infrastructure. And the basic idea is, as seen in this figure, if Alice is infected in day 0, by the time she's at day 2 or 3, she is infecting other people. But then she only realizes at day 5 that she has symptoms, and then she has to get a swab test, hopefully, on day 5. Those tests should then come back. She'll be self-isolating, hopefully, by the time she has symptoms. But there's a 72-hour window, maximum, ideally a 48-hour window, between when Alice has symptoms and her contacts from the days before have to be identified and quarantined. Now, the speed of testing is as important, if not more important, than capacity. In Ireland, we're very proud of our large testing capacity. We've tested a lot of cases. We're one of the highest countries in the world for testing capacity thus far, but it's been far too slow. And when we come out of lockdown, having a slow testing capacity is next to useless. It is useful for estimating the prevalence of the virus in the population, though so far, I think we still don't have a good idea of what that's been. But it's really no use for isolating people. In lockdown, everyone was isolated because we had general universal isolation. Now we need targeted particular isolation. And so we need to be able to identify contacts who will be pre-symptomatic or asymptomatic within 2 to 3 days of people getting the symptoms. And so the system has to have information, of course, but it has to have speed and it has to have consistency. It's no good to hit targets for a few days. You need to be able to hit your capacity targets with a 24-hour testing turnaround every day, 7 days a week for many months at least. And then we need to have contact tracing in 1 to 2 days, and that leading to clear guidelines for contact quarantine. And this is assuming no delays, of course, in information transmission between the testing operation and the contact tracing operation, and reliable quarantine of all those contacts. Ideally, of course, all these primary contacts need to be tested the day they quarantine, because if they're not, then they will have to quarantine for 2 weeks, which is a cost to them as citizens and obviously a cost to the economy. We want to test them so that if they're negative, a day later they can rejoin society. And if they're positive, obviously they should self-isolate for 14 days and may require medical attention. If they can't self-isolate at home, then we need to provide facilities for them to isolate in, as has been done in South Korea and in other countries. Now, then the other reason for testing primary contacts is not just so they can exit quarantine early. The other reason why we will want to test primary contacts is that this will be key to hunting out the virus in the population. At the beginning, we're probably going to have somewhere between 100 and 150 new cases per day in the population. So we're going to be testing 15,000 people per day. And that's not including what we should be doing with healthcare workers, etc. So at the beginning, we probably won't have a lot of spare capacity for testing secondary, tertiary, and contacts and so on. But as we begin to get the numbers down, or we scale up capacity even further, we should be in a position to test contacts of contacts and contacts of contacts of contacts. And if we do this in a proactive way, we can really, I think, eliminate the virus from the island entirely, which would be, I think, the most reasonable and practical way for the active suppression of the virus in the community. And in the simplest case, I think the throughput would look something like this. Really, we would be doing this for both PCR-based testing and antibody testing. We don't yet have antibody testing in this country. We need to develop that. But in concept, a person would present themselves with SARS-CoV-2 symptoms. They would then be swabbed, I think, reasonably within 6 to 12 hours after that. I would suggest removing doctor referrals from the process. There should be a 24/7 call center that they can get in touch to schedule either at-home tests or tests in test centers to sample from the putative patients. Testing needs to be done within 24 hours, ideally, of them reporting symptoms, with the results communicated to them and then to the contact tracing operation. All contacts, being the people in pink, would quarantine and then be tested themselves and re-enter the population if they can. And then we search for secondary, tertiary, and quaternary contacts. Now, one way of doing this would be a regionalized approach. And the islands off the West Coast may present an opportunity for doing so. So we know that the Aran Islands are free of COVID-19. Achill Island is not. And Achill Island has had approximately 10 cases of COVID-19 that we are aware of. Now, we don't have very good current data on this, so it's possible that there is no more COVID-19 on Achill Island. So I only use this as an example. If Achill Island is not appropriate, we could use either a different island or else a defined geographic area on the mainland. But the idea would be to identify a specific geographical area, test everyone there, identify and isolate all positive cases, and then regionally release lockdown in that area after it becomes clear of COVID-19 and limit access to the area. And to show ourselves and to show the population how quickly, potentially, the virus can be essentially hunted out through proactive testing and isolation. And you may be aware that the Nobel Prize winning economist in the United States, Paul Romer, is actually arguing that instead of test, trace, isolate, we should test everyone regularly. That's not currently practical, but there's no reason in the future why something like that couldn't become practical. I think it would certainly be financially worthwhile. But I think we can test everyone in defined areas just to see how quickly then we can actually remove the virus from those subpopulations and use it as a model for developing an inclusive strategy in Ireland that the population will buy into. Now, we are, I think, currently looking too much to Europe and not enough to Asia. I think we should be looking at South Korea. We should be looking at Taiwan. And obviously we look with envy at New Zealand. But at the moment, it seems we're talking about what different countries are doing for their exit strategies in different parts of Europe, even though most of them are not yet tested. Suppression has already been achieved in some European countries. By suppression, I mean no or effectively no new cases of COVID-19. Iceland, Greece, and Austria, I think, are the best examples of this, particularly Iceland and Greece. They did this, however, mainly through, like New Zealand, mainly through the effectiveness of their early measures, mainly through the effectiveness of their lockdown and how they managed it. And in the case of Iceland, it did involve a heavy testing component. How they fare coming out of lockdown is a different question, but certainly Iceland and Greece have advantages of geography that we also have. And Finland, I think Finland is very interesting at the moment because though Finland are not at a suppression stage yet, they have similar They're very similar to Ireland in terms of population. And the scientific community in Finland is currently pushing for proactive test, trace, isolate suppression strategy. And Juha Tervala, who's an economist at the University of Helsinki, has estimated that the exposure to the Finnish economy is up to 100 billion euro in growth and lost tax revenue of 20 to 40 billion euro. And back of the envelope calculations for an aggressive test, trace, isolate infrastructure would be 1 to 3 billion euro, given that we're planning on spending 1 billion euro a year on personal protective equipment. The cost of an aggressive test, trace, isolate suppression infrastructure would be negligible, and it would be an excellent investment for Ireland. There was no COVID-17 or COVID-18, but there could well be a COVID-20 or a COVID-25 or something else. So having this type of infrastructure in place would be very effective for an island, but it would also allow us to deal with future pandemics without lockdowns and without waiting for vaccines. So I think it's a logical approach, but it's also organizationally the most challenging approach from the perspective of government. And just to conclude, this is my last slide. I think what this would look like, if we want a regime of secure active suppression in Ireland, which will allow us all to get back to a normal economic, social, and educational life, we need to be testing all symptomatic people. We need to quarantine and test all of their asymptomatic contacts. And then we need to test them so that we can test their contacts. That's crucial to finding the networks of infection. We need to quarantine and test all incoming travelers. We're a highly globalized nation. We do not want a protectionist situation. It would not suit us. It would not suit our economy. We need to therefore be testing everyone at the airport, as we're seeing in some Asian countries, or we need to be testing people in controlled quarantine situations for the first day or two after they arrive in the country, and we need to be enforcing this. We need regular testing of all healthcare workers. This is essential. A very nice study was done by Gordon Dugan's research group in Cambridge recently. It was published a few days ago in eLife. They did random testing of over 1,000 healthcare workers in Addenbrooke's Hospital in Cambridge, and they found that 50% of all healthcare workers carried SARS-CoV-2 at the time of testing, actively carried the infection. 57%, sorry, 3% of all healthcare workers carried the virus, but 57% of that 3%, so half of that 3%, were truly asymptomatic, and asymptomatic people spread the virus. So this and modeling studies from Imperial College London make it very clear that if we regularly test all healthcare workers, that means every 2 or 3 weeks, every healthcare worker gets a PCR test. We will certainly reduce the transmission of the virus in the population significantly. There's a lot of talk this week about schools. We have to be very careful with this. Children are not super spreaders of the virus. They are, however, spreaders of the virus. We know that children do transmit SARS-CoV-2. They probably are not a huge risk of infection of symptoms themselves. We don't know, however, whether or not children are less likely to be infected. So it remains to be seen how we should manage the child population and schools in September. But it seems to me that whatever happens, we should at least have sentinel testing of sample groups of children in schools across the country. And certainly we need random population testing. But if we get all of this in place, and if we take advantage of our geography in doing so, through an all-Ireland approach, most likely, I think that we can see ourselves coming out of this through an active suppression strategy very quickly. And there are obvious economic benefits from doing this as quickly as possible. relative to other countries in Europe. And thank you very much.
Thank you, Tomás. That was incredibly interesting, and we're getting loads of questions in. So your presentation has really stimulated a lot of questions, a lot of debate. So we'll get to that in the Q&A session. Just to respect time, I'm going to ask Pat to come on board now and give his presentation.
Okay, you'll have to start the video for me.
Yeah, just have to. Tomás, could you stop sharing your screen, please? Let me see. Thank you. And video. Okay, there you go, Pat. We can see you now.
Okay, folks, listen, good morning, everybody, and thanks to the organisers for inviting me along. My name is Patrick Wall. My background is I'm a vet and a medical doctor, and I'm a professor of public health here in UCD. My previous experience with the coronavirus, with the first cousin that causes Middle Eastern respiratory syndrome, it's a condition that's spread from camels to people, and I worked in the Saudi with it, you know. At the moment, what I'm involved with is setting up with my colleagues here in UCD a voluntary contact tracing centre and training people to work in a testing centre so that we can build capacity. Basically, you know, what I just do is give you an overview of how we got to where we are. The lockdown that we started in Ireland was intended not to last forever. The initial rhetoric was that it was to buy time by reducing transmission, to tee up the health service to cope with the possible surge. There was a big question mark about our ICU capacity, to build rapid testing capacity. And after Tomás's talk there, the word rapid is key. To set up timely contact tracing to enable cases and their close contacts to be traced and to get them to self-isolate, to stop viral transmission. And the key word here is timely. To identify and deal with clusters of infection in subsets of the population. And again, finally to quarantine these clusters, whether they're nursing homes or care homes or direct provision centres. And Tomás used that word quarantine also. We have to learn to live with the coronavirus. We may or we may not get a vaccine, and we can't wait for a vaccine. And so we have to get on with life. And so we have to find a way of doing this by managing the risks. Like we can't stay closed forever, and or we're going to face economic ruin. And there's a whole issue with the non-COVID morbidities. To release the lockdown, we have to demonstrate that we've transmission controlled, and the numbers are looking very optimistic at the moment. We have to be able to demonstrate that the health service can cope, and the health service at the moment has spare capacity. So if we have to cope with a little surge, we can handle it. We have to be sure that we have actually quarantined the outbreaks in the high vulnerable settings, and we haven't done that yet completely. And as long as there's bushfires burning in nursing homes and direct provision centres, the potential is there for the virus to spill back out from these centres into the community. Workplaces have to set up their structures in such a way that they can enable physical separation to enable people to return safely to work. And then we have to reduce the risk of imported cases and set up systems in the ports. You know, what I want to just give you a little flavour of how we got to where we were. Like, firstly, we didn't have a Rolls-Royce health service before this started, so that the idea that we didn't end up with a slick system rapidly, that shouldn't be surprising to anybody. I mean, if people thought that the health service was all of a sudden going to become slick in the middle of a pandemic, they'd be naive in the extreme. So in the beginning, we got the first case in February 29th, and initially it was doctors that rang the cases, the public health doctors who were the trained epidemiologists in the country, because there was a kind of I think that only a doctor could give someone the results, like, trust me, I'm the doctor. So we had the actual doctors phoning the patients with the results and looking for the contact tracing, which was manageable in the beginning when we had a small number, but it wasn't sustainable at that. But it also meant that some of your key public health professionals were on the phones. It's like akin to having the captains of the ship down in the engine room shoveling in coal, and there was nobody actually taking the big strategic decisions to avoid the icebergs, you know. Initially then, when things scaled up, we trained the Army cadets to make the calls. And there's 3 sets of calls. The first call is you ring someone to tell them they're positive and tell them what's involved with self-isolation. And then you tell them that you're going to look for the close contacts. You define what a close contact is, but people couldn't give you the contacts on that call because most people, their contacts are in their phone. So you say, well, make a list of your contacts, we'll ring you back. Call 2 is to ring back and get the person's list. You don't need to be a doctor to do that. And the third thing is to ring all those close contacts to explain to them that they could be in the incubation period and they need to isolate. So there were 3 calls. It's cumbersome enough. But initially, when the numbers started to mount up, we used the actually Army cadets to make these calls. And so therefore, you automate things when you don't have the Army to help you. But in this case, we did have the fucking Army. And so therefore, that actually gave us a false sense because the Army were very, you know, they were just numbers. We just threw numbers at it, you know. So that's what was happening, and we developed a script for each of these calls, 1, 2, and 3. So that was actually undertaken in Dr. Stephen's Hospital by the HSE, and around the country, the public health doctors in their departments were continuing to do it directly, but there was a concentration of cases in Dublin. Laboratory testing. People wonder, why didn't we set up the test? And Cliona highlighted that this test isn't a little dipstick test. It's a PCR-based test. It can take up to 5 to 6 hours. It's not simple. Hospital laboratories around the country are geared for looking after individual patients. You know, they look after the inpatients and maybe some outpatients testing. So they're not geared for looking after thousands of patients, and some of them could scale up to do a few hundred. The NVRL is the reference laboratory. Again, on a good day, the reference lab could do about 1,200 of these tests. So it wasn't geared up for doing thousands, you know. So we didn't have a laboratory capacity to do, we haven't got no high throughput lab with a rapid turnover result. So the politicos then set up 30 swabbing centres around the country, but they kept calling that we had 30 testing centres. So the public were assumed that they were going to a testing centre when you're going to Croke Park or Tallaght Stadium or wherever. And so we were collecting all these swabs, but at that time we were collecting 6,000 swabs a day, and they were pouring into the NVRL, which had the capacity to do 1,200. So we were building up a backlog. So if you think of what Thomas said about timely testing, there was no way it was going to be timely there. So this has led to a lot of frustration when people couldn't get the results or they couldn't get contact trace. So we built up that backlog. There was only a couple of laboratories in the country that had the capacity to do high throughput turnover, and they're the veterinary laboratories. And one particular lab, Enfer Scientific in Naas, it does all its work for the Department of Agriculture outsourced, but that actually specializes in numbers and turnover. And during the last calving season last year, they did 1.5 million PCR tests for a viral disease in calves. And the farmers gave them a bollocking if they don't get the results back in 48 hours. So the idea was that we were to engage with Enfer. And so initially discussions were ongoing with Enfer about could they come onto the pitch. They were concerned about indemnity. And so the idea that they had to seek indemnity from the state's claims agency, and there was quite delays over that. Anyway, they were keen to come on the pitch, and they ordered 250 of the roach extraction kits. Basically, when people said there was missing reagents and we were scarcity of reagents, it wasn't just as simple as reagents. The reagents are actually, it was DNA or RNA extraction kits, and they're akin to the cartridge in a printer. And so you have to actually have the whole caboodle, and so they became scarce. So then by the time the indemnity came through, there was a scarcity of those reagents, and so the lab had to be kitted out with a completely different system. That system had to be validated to make sure it was compatible with the previous system. So they used a Perkin-Elmer extraction kit. It had to be validated by NVRL, so that took up time. The results from the different laboratories, the 20 labs, hospital labs, and Enfer Scientific, they actually they didn't link in automatically into the contact tracing database. So there was manual entry. Can you just imagine that? And the backlog of swabs were sent to Germany. Again, the results came back and all had to be manually entered into it. That took days, and there was always potential for error. Then the Department of Health decided they were going to do a massive nursing home survey. And the nursing home survey, that was different in that up to this, we were only going to positive cases, but the nursing homes, which we were slow off the mark to batten down the hatches with the nursing homes. We knew from China and from Italy and from Spain that old people were taking the brunt of this, but our nursing homes, our end of care homes, they're not geared up for looking after clinically ill people. And so when it got into some managed well, some got into big trouble. But when we decided to do a blanket testing of the nursing homes, the nursing home managers wanted to have negative as well as positive results to roster staff and to cohort patients. So the Department of Health announced on a Friday that they were going to do a nursing home survey, and the HSE had to operationalize this on a Saturday, which you can imagine that was challenging. A lot of the non-glamorous caring jobs in the nursing homes are done by non-Irish, and it is actually this has shone a light on the whole way we look after the elderly. And basically, the new Irish are looking after them lowly paid jobs. Sometimes they're on 0-hour contracts, and so it's far from satisfactory. And this is a huge issue that we'll have to resolve in the future. But it uncovered a whole weakness in our system. So basically, Ireland we're supposed to be an IT country, and but we didn't have any linking of the results into the contact tracing site until last week. So now it's working a bit slicker now, but like that's just I've galloped through that because I'm conscious of the time. But basically, going forward, we now have a system that actually can test results quickly, and the NVRL NFIR complex is actually as slick as any testing center in Europe. Why did it take us so long to get here? There's many explanations for failure, but there's probably no excuse. But going forward, if we follow the regimen that Tomás suggested, we need to protect the vulnerable in society and protect the healthcare workers and carers, and have rapid surveillance to pick up the clusters and do that timely testing. We now have over nearly 24,000 cases in Ireland. So if we actually analyse our own cases, we can actually get a good idea of the epidemiology of the disease in Ireland, who's getting it. And when you take out the nursing home residents and the frail elderly and the people with concurrent morbidity and the healthcare workers and the care workers, you can see exactly who's getting the disease and who we need to target for ongoing testing. We've had actually issues with meat factories where a lot of the workers are migrant workers, and they live also in overcrowded conditions where it's not possible to self-isolate, and where it's inevitable that virus will transmit. The HSE has set up a centre in City West where people who can't self-isolate at home can go, but it's not that practical for people to go from rural areas to the City West, so we'll have to resolve something there. But basically, I'll stop there because I know that there'll be questions, and I'm conscious we've gone over time. Thanks, Orla.
Thanks, Pat. That was incredibly interesting, and also just to figure out and find out how testing is working on the ground in practice. So that was really useful. Okay, I'm conscious that we've lots of questions, so we're going to move on to the Q&A session, and I'd like to invite all our panelists to come back on board. I think Pat's there, Tomás is there. Cliona, are you?
Yeah, Orla, can I ask a question to start? Yeah, I'd like to comment. I mean, I really appreciate, Patrick, the rundown you gave of everything, and I actually fully appreciate the challenges that we face as a country in setting up this infrastructure. I don't see how you can be so confident that we're currently set up well. 2 days ago, the stated aspirational turnaround times by government were not sufficient to catch pre-symptomatic transmission. Yesterday, the chief executive of the HSE then stated that next week, new targets will be introduced that will be about 72 hours, hopefully just about adequate to catch pre-symptomatic transmission. Next week, we come out of lockdown. So next week, new targets will be introduced that supersede the targets of 2 days ago. The targets of 2 days ago would not prevent pre-symptomatic transmission, and the targets of 2 days ago have never been achieved in themselves. So I'm quite alarmed by the current situation. On top of that, there is no evidence of electronic contact tracing being a part of this component. There are huge doubts about the error rates in the manual contact tracing operation, and the capacity for lab testing has not in itself been that consistent. So well, I appreciate these, but
well, the first thing, Tomás, if you believe all you read in the media and hear in the media, you eat all you see. So we've had a lot of rhetoric that doesn't stack up now, and so a lot of what we've done to date has been well substandard. in the contact tracing. All I can tell you is that I'm here in the contact tracing center now, and the contact tracers are tracing people that were tested yesterday. You talked about an IT, when I was talking about IT link, I just meant an IT link from the lab to the contact tracing center database. I wasn't talking about apps or anything more sophisticated. And I fully accept, I don't know why we weren't using chatbots and all kinds of things up to this, but we do have a laboratory now that can actually turn around samples in 24, 48 hours, and we can get to people in a meaningful timeline. We couldn't do this before now. And we've had all kinds of delay, like manual entry. I mean, that's state of the art. Not state of the art. And I thought that in Ireland we had all these Googles and Facebooks and everybody else. We should be much slicker.
Patrick, respectfully, I don't agree with much of what you said. I'm a professional scientist. You tried to communicate to everyone here that these are complicated tests. These are not complicated tests. A first-year undergraduate can do one of these tests in 4 hours.
Yeah,
they are the most basic.
Can you do 15,000 in 4 hours? No, you can't.
That's a different thing. No, it is an industrial problem. Yes.
Yeah. We set it up. It's there now. You can come and visit the lab if you like, if you don't believe me. Blessed are those who have not seen yet believe.
Okay, I think we should move on to some of the questions that we got in the Q&A session. So one of the first questions we had is for Cliona. Cliona, this is a question about Ireland's kind of comparative advantage in terms of doing research on coronavirus. So the question asks, does Ireland have the research capacity to conduct fundamental research to learn more about how the virus works, who it is most damaging to, and what we can do to fight its spread? So what is our comparative advantage in coronavirus research in Ireland?
Yeah, well,
if any.
Ironically, we do actually have an advantage. One subject that we're particularly good is basic immunology. So we have some really wonderful basic immunologists, Kingston Mills, Luke O'Neill, Lydia Lynch, Paul Moyna. And so as a group, it hadn't been hugely supported in the past research-wise as an entity, but it's looking like that there is much more support now because it's recognized that that has to be done. So there's a very big proposal under review at the moment, which if there's a public announcement about that will demonstrate how all that expertise is being brought together. But inevitably, the best institutes in the world are dealing with this. So it's moving unbelievably quickly, but because of the level that we're functioning at, we've contact with many of those people. So I do think that there is a possibility, there is a potential for Ireland to really contribute significantly. Okay. I don't know if that really answers the person's question, but I'll look back and add a little written note.
Okay, that's great. Tomás, a question for you. How much does a different approach in the UK, Northern Ireland, undermine our own approach from here?
Yes. However, I would be optimistic.
Mm-hmm.
You know, we look back to the foot and mouth crisis, and even extreme unionist voices took a very all-Ireland approach at that time period. I think that while our testing and tracing infrastructure has not yet been proven to be what it needs to be, though I'm hopeful. I think we're in a better position than the UK. I think the UK government has obviously made some of the worst strategic errors in Europe. So I think that in combination with the fact that Northern Ireland, Scotland and Wales have shown themselves to be at odds with what's been decided in Westminster, if we can lead in the Republic of Ireland, that I think it will be pretty straightforward to get Northern Ireland to come with us on that. So I would be cautiously optimistic that would be a problem that will hopefully take care of itself. However, the problem is a problem, and we can't pretend that it's not an issue, but it's not a reason to give up. It's not a reason not to try.
Okay, that's great. Thank you. Question for Pat now. Pat, your thoughts on the use of automatic contact apps and given how important adoption rates of such apps are to succeed, how we might get social buy-in to download and use such apps?
Yeah, it's something that I thought from the very outset, and like I was as impatient as Tomás still is with the system, but you know, like I thought we had Google and Facebook and all these, and that everything would be automated. And so we've heard a lot about this app. I don't know much about the app because I'm just here on the old phone system, but the idea that it needs a Bluetooth handshake to shake hands with people, and if you look at the people who are actually taking the brunt of this, they're an older subset of the population, and are they going to be on these apps? I actually don't understand why it's taken so long to do everything. And, you know, when Thomas says, are we there yet? Are we there yet? It's like that Goethe ad. Like I was the same for the last 10 weeks. We've been saying, are we there yet? And we have a system that works on the phones at the moment. But if it takes us long to actually come up with a smartphone app, as it's taken us to just do a simple thing like download results from a lab onto a database so people can manually ring, I wouldn't hold my breath for it now. I'm disappointed. And you know, what Thomas outlined in his talk is fairly simple. If you want to break transmission, you have to be quick. And we haven't been quick enough to date. And now, Thomas, you can come back and revisit me in a week to see if my optimism is real at the moment. I think we have the system now. I'm intending samples away out to Germany and hoping we get them back within 48 hours to ring people. It's crazy, crazy. So am I optimistic that the apps, of course, I've seen the IT guys, I've seen demonstrations of some of these, they look really slick, but the move from a pilot to operationalizing it, if what we've done to date is an example of what we're capable of doing at speed, I wouldn't be overly optimistic.
Okay. Thomas, do you have anything to add about the apps, the use of apps? Okay.
Can I come in on the
apps? Yes, Thomas, sorry. Yes.
Just to say, I mean, I think electronic contact tracing is going to be very, very important. I don't think we can do it based on what we've seen in other countries. I think it would be foolish to think we can do it without good electronic contact tracing. So I think this is an urgent issue. Singapore, often described as having a second surge. They didn't really have a second surge. What they had was a very delayed first surge. They had things under control. At the beginning, they lost control for a number of reasons. One of those reasons was their contact tracing was entirely manual. And electronic contact tracing is necessary, particularly as we get back to normal. So it's one thing if I ring you and I ask you who your contacts were, we can learn about the people you're in touch with. We can't, however, learn about who you sat beside on the bus or the train. We can't learn about who you were beside in a shop or embarrassing contacts that you may not want to talk about. Electronic contact tracing allows us to identify all those interactions. And I think that's very, very important. We can either do it the South Korean way or a more moderate way. The South Korean way is quite invasive from a privacy standpoint electronically, because it means we use your GPS data, your credit card data, and then it's integrating that with CCTV footage of any public place you've been in to try and figure out who you were in touch with. A less invasive way is a Bluetooth situation, where the information is stored locally on your phone. The government don't have central access to it. And when someone tests positive, you would get a message saying you are near a positive person. We regard you as a close contact. You need to quarantine at least until you have a negative test. Bluetooth apps have been shown to be effective, but they need to be opt-out, which means most people need to have them. About 80% of the population need to be carrying them. Because even if 80% of the population are carrying them, the chances that two people, that one given contact of two random people would result in the two Bluetooth systems talking to each other is only half of that, because you have to multiply the probabilities. So if you have even lower than 50% of people carrying this, it's almost useless. So we need some kind of a Bluetooth situation where most people are carrying it, at least in cities.
Okay. Orla, could I come in there to ask a question, because I can't submit a question through Q&A.
Yeah.
So I'm wondering, first, is there some way of incentivizing people to sign up to these electronic testing systems, particularly, for example, young people? If we could give them free downloads or free service or something like that. It's an investment, but it could boost the number of people who are on the system. And while I'm talking, another question for Cliona: is it possible to imagine self-testing rather than the elaborate medically testing that we're doing at the moment? It seemed like it might speed that process up. Thanks.
I'll answer that. I'll answer very quickly, because then I'll let Tomás, or I don't know who answered the other one about the incentivizing people. But yes, absolutely. I think we have to introduce, and somebody else has a question there about what we should prioritize. There's evidence that the saliva is actually a much more reliable source of the virus, and it might also be able to tell us immunologically what's going on. So we should be absolutely focusing on some sort of test that can be done either just through a company that people submit saliva, or they do it themselves. And I think that's absolutely feasible, and that would be a priority. If I think that should be a priority.
Okay. Cliona, we've had a couple of questions come in about the statistical properties of tests directed to you. So maybe you might answer that. So someone asks, so on balance, how much evidence have we on statistical properties of different types of tests, or is it too early to know?
Yes, I saw that. Cathal, I'm sorry. I thought I was going to type an answer and I pressed a button, and I'm sorry, it didn't go properly. But yes, the evidence, there's a huge amount of reviewing going on. But to actually see them how they're performing in the field, you need large numbers of people over a particular time, and you need repeats, and so the data just isn't there yet as to which is successful. And so it's just emerging now that this regular PCR, which everybody thinks is the golden rule, we know that there's false negatives there, that it misses people, and there's all sorts of reasons as to why it misses people. And this comes back again to the saliva issue. If anyone has had that swab test, it's horrible. So I think whereas the saliva test we can see is just completely different. I just cannot believe that we're not switching. But anyway, don't get the Philip's question lost though, about incentivizing. I don't know who you want, because the economists need an answer to that. I don't know who you want to get to answer it.
Okay, would anyone like to answer that question about how we can incentivize people to download and use the app?
I think one way of doing that is in South Korea, the systems they have also tell people where there's high concentrations of people with the virus recently identified. So the app should come with not information about individual people, but saying, you should not go into this area of town today because somebody there has been an active spreader. That kind of information, I think, would be a strong incentive for people.
Okay. Sorry, Tom, go ahead.
Oh, and the other thing I wanted to say, based on what Cliona said, there is very good evidence that saliva is a way of testing for this effectively, but it also allows us to have at-home sample collection. I don't want to get too much into technology development at all here, but it's very possible that in 4 to 6 months, we're going to have at-home test kits anyway available, because a lot of labs, particularly in the US, are trying to develop new ways of testing, not for the antibody, but for the virus itself, which, if they can be scaled up, would allow people to self-test. That's not currently on the agenda. What should be on the agenda is self-sampling, which means people sampling at home as soon as they get symptoms, and somehow some courier system that brings it to test centers would, I think, take a lot of time out of the process.
Exactly.
That's not a radical suggestion. It's important to note that in the European Commission roadmap, which they want all countries to use, one of the central recommendations is to find ways to have at-home sample collection. So that's it's not a requirement to exit lockdown, but it's a central recommendation. So I think that would be a good way of moving forward.
Okay, now we have loads more questions, but I'm very conscious of time and that we've ran over. So I think we probably need to end the session there. It's been incredibly interesting. Thank you to all our panelists and all our audience for their questions and participation as well. As I said, this video or this session has been recorded and will be made available on publicpolicy.ie over the next couple of days. So please stay tuned to that. Once again, thank you everyone. It was a really, really interesting and thought-provoking session. Thank you.